So as mentioned, I'm Brandon Caldwell, Global Product Manager for Framatome, focused on our liner and coating solutions. And this evening we're talking about their buried pipe rehabilitation solutions to support extended operation of nuclear plants for this E4 Carolinas Alumni session. So we'll cover Framatome's liner and coating solutions and talk a little bit about the need for these solutions within the nuclear industry and the energy industry overall, and then what those solutions are. So first, I want to look at the what's driving a need for innovative buried pipe solutions. So from an industry focus point of view in the nuclear industry, which Framatome, those that don't know, Framatome is a nuclear engineering vendor and service vendor supporting the U.S. and global nuclear energy power generation fleet. So we saw a huge need as plants are aging and getting older for rehabilitation solutions for some of the buried piping and other assets to support plants going into extended operation that I'll talk through here. So what's the driving factor for Framatome getting in and developing this innovative buried pipe solution? It's really the industry focus on aging of the fleet. So many original components and structures and systems are beginning to surpass original design life. The average age of our U.S. Nuclear power fleet is 41 years. If anybody's familiar with nuclear plants, they were originally licensed for 40 years of operation. The majority of our operating units have been extended to 60 years of operation, and now they're working on what's subsequent license renewal, which is 80 years of operation. So the plants are getting older, components are degrading and going past what they were originally designed for. The other piece is not only are they past what they were originally designed for, but plants are extending their operating license to another 20 years. So you have an 80, you double the life of that plant that was originally designed for 40. And within that, our regulators, the Nuclear Regulator Commission and others, develop guidance and rules and laws that have to be abided by to go to subsequent license renewal. And a lot of that is to ensure that system structures, components are adequate for what they call that period of extended operation, PEO. And to do that, there's several reports, new regs, regulatory guidance documents, and licensing actions that have to be taken. But within that, it determines inspection, monitoring, upgrades, changes to plant design, or changes to systems that would be required before you enter that period of extended operation. And just for reference, there's currently over 70 plants that are either some have their license to 80 years, some are in review, or some have made commitments to do that. And at the bottom of this screen is a typical time frame for doing that license renewal. So you would enter in a period of extended operation at T0, but you may be making decisions as a utility up to 15 to 18 years before you enter that time. And what's key, what drives this all, connects this all to buried piping is what we're talking about with repairs. So the actions may be required for a plant to do upgrades, which include doing modifications or upgrades to their buried piping or tanks or other buried structures. And those repairs have to be done before they enter a period of operation. But a lot of these repairs are not small and take many, many years. So that's why plants are planning out decades in advance of entering a period of extended operation to ensure that they have the plans in place. And that's where this buried piping solutions support that extended operation. So why, that was an industry focus, but looking at a utility focus, so why is this technology important? And we'll get into the details of what the technology is. But the nuclear fleet, power generation fleets, is needing innovative, efficient solutions. Utilities, not just nuclear, but all power generation, are looking for solutions that extend the lives of their systems and increase reliability, all while reducing that cost and the risks that come with operations. And any type of upgrade or modification has to be economical to support any plants facing competitive markets. So there's that innovative, efficient solutions. There's also increased focus on raw water system improvements, buried piping improvements, because at least in the nuclear energy, with plants aging and going to extended lives, as we mentioned, there's a need, and the need for expanding innovation. Plants are turning their focus toward their secondary side of the nuclear systems, which would be the raw, secondary and tertiary side, which would be that raw cooling water systems. And these systems may have not seen that level of focus that in the past as they went through their 40 years and 60 years of operations. Also, plants have key strategies around buried piping upgrades and needs to make sure that they meet the actions that are given to them before they enter into that period of extended operation. And some of that includes additional monitoring, inspections, as well as full replacement of buried piping and buried assets, and that's where this liner comes in as a potential alternative to that. And also, the degradation of buried piping and assets issue faces nuclear as well as all electric utilities, and have unique issues and degradation mechanisms that require unique and economical solutions. So from an industry, nuclear initially, Framatome's nuclear focus, but also applicable to the overall energy industry. Some focus points issues, aging, degraded components, that's across the board in our power generation infrastructure. Buried systems are critical obstacle to pursuing life extension. There's actions and initiatives in place to mitigate that degradation before plants go into that 60-plus year operation period of extended operation. Need for economical solutions to extend the lives of these systems, and the need for a qualified liner economical solution to resolve the needs. So these industry needs issues require an innovative solution. So that, as Framatome, we see this need across all the utilities, and so we come together to bring an innovative solution to address those needs, and that's through the coating and liner system that we have and are developing and deploying. And that's a partnership with Framatome. So we're a nuclear vendor partner. We service, do engineering and services, and design plants, design and deliver nuclear fuel. So we see the full gambit of services for nuclear power generation, and we saw this need. So we went out and partnered with a company, Nucoat Coating Systems, which is an industry leader in elastomeric polymer production as well as application. And so we have exclusive teaming with them to bring a proven solution to the energy industry for buried pipe rehabilitation. And we'll talk a little bit on what the details of that is, a combination of Framatome products and services and the Nucoat coating system in order to satisfy all those needs and issues that we talked about. Overall, what we have is a three-part liner solution with the Framatome Nucoat sprayed in place piping, which is an elastomeric polyurea with the Framatome, has a Cortec nano film, thin film coating, and that provides that spray in place liner that becomes the new pipe, in effect replacing the buried degraded assets and allowing those plants to get to extended operation. And we'll talk a little bit about the product itself as well as application methods. So, a spray in place piping, no loss in system hydraulics, so there's concerns with hydraulic losses, and it's a seamless system. So with that product, you've got the application method, which is done robotically and remotely. So you have robotics controlled and going into the pipes to apply this liner, expediting project execution, reducing safety and cost, risk, and uncertainty. And this tooling is specifically designed for remote in-pipe liner application through existing access points. The robotics, perform the duties effectively, ensuring, that you have a liner that per design with efficient product usage, which results in, efficient and an economical solution. And then the third part of our three-part approach is the design engineering, and that's where Framatome, with us being an original equipment manufacturer for nuclear, we have the engineering capabilities to do the structural hydraulic analyses and evaluations, the modifications, the design changes in order to implement the liner system to resolve all those industry and utility issues that we started the presentation with. A little bit about the polyurea product itself. It is a spray-in-place liner, and I'll talk through a little bit of the details here. So it is a fast gel elastomeric polyurea, and it's spray applied. It has structural capabilities through a structural polyurea product, as well as erosion and impact resistant capabilities. So the combination of these two products provides that liner system. It is fast setting, so it's got a very quick tack-free setting, so it allows you to apply it in a forward and reverse application, a layered approach to get your design thickness for whatever that specific application is. And with this product, it is a extremely fast curing, so it allows for that return to service of systems. So the issues and the options that plants have to deal with the degradation and issues for buried piping is really dig up and replace, which is a very costly and time-consuming process, or it's abandon and reroute, which again is costly and time-consuming. And then there's also other internal piping options, maybe with an epoxy liner or a carbon fiber wrap. All of those very time-consuming, either very manually intensive or have long cure times. With this product, with the robotic application and with the fast setting, you're able to do it very quickly and having your system outages minimized. With the tooling capabilities, have a wide range of piping. It could be applied to 8 inches and up to 12, 14 feet piping. Application around elbows and various configurations are possible. With this product, it's environmentally friendly, so it's no VOCs, which stands for volatile organic compounds. It's inert. It is approved for drinking water, so this product has its genesis in water distribution, municipalities, water treatment facilities, oil and gas industries. So it has the certifications to be used in drinking water systems. It's in use today as a rehabilitated solution for drinking water systems, and so it's got the environmental accreditations that come along with that. Project installations in use for more than 15 years, so it is a proven solution. It's not something new. We as Framatome saw the huge need and are bringing it into our industry, into the nuclear and energy power generation industry. But it's been around, again, like I said, in water treatment, water distribution, oil and gas applications. Engineered specifically for each pipe diameter and application type, so the application method, the thickness of the liner is all designed depending on the specific needs. And the product has a design life of 50 years. So going back to that, extending the life of the plant with a design life of 50 years, you can apply it into your buried piping, and it's good for the extended operation of that plant. Overall, an efficient product that can provide that structural capability and degradation protection to resolve those issues with buried piping that we face within nuclear and within all energy. Just a little bit of visual of the liner system. We have the structural portion on the left, that dark gray, and then that light gray being our elastomeric portion, that erosion resistant, and then the top coat, which is the corrosion resistant. And all that comprises our liner system. This has been tested. You can see on the right a compression test of a segment of the liner. It's tested and qualified in many instances as a fully structural liner solution. some before and afters. Most berry piping, as I mentioned before, are beginning to surpass original design life. So within nuclear power, we have dedicated cooling water systems, emergency cooling water systems that are linked to the ultimate heat sink of our nuclear plants that are required to stay operational and functional throughout the life of the plant. And these piping assets are degrading, and they were designed originally for a 40-year function, and they're surpassing that. So it's causing additional risk, additional maintenance costs, additional monitoring for these plants to continue operating these vital cooling systems. And so this liner can be applied with all the benefits mentioned and be able to restore that system and have it operational and functional for well into the future and throughout the remaining life of the plant. So you can see kind of a representative before and after before, and that's actually in fairly good condition. You have corrosion, pitting, maybe previous coating products being delaminating from the surfaces. And then you have general wear and thin wall of the host pipe. And then with the liner on the right, you can apply it, engineered to a specific thickness, for the structural loading as well as future degradation and corrosion resistance. A little product comparison of the different products, so the polyurea on the far right, and then some of the other more traditional lining, cement mortar lining, epoxy, polyethylenes. Those are all been used throughout the industry and have their purposes. But the polyurea with the structural aspect that allows you to have that high tensile strength and that good chemical resistance, as well as you've got the adhesion and the hardness ability, and the return to service is key as well, with a very quick return to service. So several positives with the polyurea product. Another comparison kind of qualitatively with the structural properties, excellent with the polyurea structural, good adhesion, the flexibility of the product far exceeds that host metallic pipe, and then you've got good corrosion resistance, chemical resistance as well, and the curing time again allows it for rapid return to service. So that's a little bit about the product. Real quickly on the robotic application technology and the tooling itself. So we have two main application methods, either a spin cast application or an orbital spray application. That's dependent on the size of the pipe that is being applied to. And the spin cast application is a winch pulled system that has visual capability. So you've got eyes on your application throughout the process. It can reach up to 400 feet in the pipe, navigate around most 45s and elbows, and has that flexible capability. So that's for the smaller bore piping. For the larger bore piping, you've got a four-wheel drive orbital spray rover that could go in. It's steerable. It's got 360 rotation applying our product. Again, it's got the high-def camera visual, keeping eyes on application. It can reach up to 1,100 feet or 350 meters in the piping, depending on the access points. And it's adjustable to adapt for various piping configurations. So overall, the robotic applications reduces that safety concern, eliminating putting people into very confined spaces. A little bit more on the robotic application technology. So we've got the orbital spray header up on the top left, and on the bottom right, the spin cast unit. That's spring-loaded legs keeping it centered, and as well as a spring-loaded chassis center, allowing it to navigate those bends and turns. And I've got some videos that are playing there. On the top left is the orbital spray header, applying it, rotating around. That's in a 36-inch pipe, and then the spin cast unit rotating, and that cone rotates at 10,000 RPMs, applying a design layer thickness of this structural liner onto this pipe. That one's navigating around a 24-inch 90-degree elbow at the moment. So you can see the liner being applied, and it's applied in a layered approach until you get your design thickness, whatever that engineering specification calls for. So why automation of our spray-in-place piping? Why that's important? Our product is a two-part product, and it gets mixed, and it's temperature and pressure controlled. And those parameters are critical to achieving liner properties. And so our robotic technology monitors those temperatures and pressures, ensuring we're staying within design. Obviously, meeting design liner thickness is critical. The charts below show, the middle one shows the application thickness variability, manual application versus machine. You can see you get a more consistent thickness throughout a pipe doing it robotically. And then material consumption directly relates to total product costs. So doing it robotically over the course of piping, you could save, 23, 25% of product consumption, thereby being more efficient. The robotic tooling monitors and records all your critical application parameters, ensuring that you're staying within spec and within design throughout the process. Some of the remote installation details that we're deploying. It's an independent installation equipment. It's all confined, able to go deploy out to a site to intake or discharge cooling water systems. Go into an access point either through a manhole or a discharge or suction end or plain spool pieces, and it's all done with minimal site laydown space, which is critical. In any power plant, power generation, if you've got outages, you've got a lot going on, and real estate is valuable. Being able to deploy this with minimal site laydown space, minimal auxiliary support needs, and able to deploy this efficient solution. So we mentioned the wide range of pipe sizes that are used for the polyurea spray in place. It supports 8 to 6-inch piping and up. We look Framatome. We work within nuclear. We know what within the buried piping and buried assets that we have at nuclear sites. There's a wide range of pipe sizes. So basically 30, 36 inches and up. Most of those pipes allow for manual entering of those pipes and can have manual pipe rehabilitation applications done, like a carbon fiber wrap where it's manually applied within the pipe. But there's a huge amount of piping, whether it be fire protection piping, circulating water, emergency cooling water piping that is 30 inches and below, most of it in the 12 to 24 inch range, that is not manually accessible. So you have to go and develop a remote robotic liner application method, and that's what this spray-in-place piping is. And so there's a large industry need to rehabilitate those pipes to ensure that they support extended operation of the plant. And that's really the focus of the spray-in-place piping through the spin cast application. So what a typical process looks like for the buried pipe rehabilitation, you would do inspections. Most plants do inspections. They have the licensing commitments or a program commitment where they're doing buried piping inspections on a every outage or annual basis. So you deploy a robotic tooling of some type to go in and do visual as-found inspections to understand that level of corrosion and pipe degradation. And then you'd have the cleaning. So based on your inspection results, you would perform your cleaning. Typically that consists of a remote abrasive blasting or some high pressure water cleaning to ensure you get that surface profile requirement, and that's all set in accordance with certain standards and called out in our design specifications. And then from the cleaning, you would do your priming where needed based on the design of the liner. So applying that primer onto the substrate to ensure liner bonding if that is designed, called for in the spec. And then application of our liner. We have our NewCode PP300, which is a modified structural polyurea that provides that structural strength. And then the NewCode STM, which is that elastomeric layer that goes on top. And then the Framatome Cortex aquatic growth reduction thin film coating is our top coat. And that combined system provides the structural capability as well as that anti-corrosion and degradation resistance moving forward. And then when that's installed, you would do post-installation inspections, as left visual inspections. You check your dry film thickness of your liner, any holiday void testing and checks to ensure you're within spec. And we have a lot of qualification efforts ongoing with structural qualifications. So, we're developing so this is a proven product within various other industries. Framatome's working to ensure within nuclear, we have to meet regulatory as well as ASME code requirements in certain aspects and certain piping. So we're undergoing a qualification process to ensure we meet all of the needed nuclear safety requirements, allowing the liner system to be structurally credited as a pressure boundary system. So this encompasses the code and regulatory requirements, ASME Section 11, ASTM, AWWA, which is American Water Works Association, as well as NRC requirements. And so we're leveraging previous testing as well as the engineering and regulatory experience from Framatome to ultimately support a regulatory and code approved process. Outside of that, hydraulic qualifications, implementing hydraulic testing of the liner and modeling to ensure that there's no impact to the hydraulics. So these service water systems, the emergency service water systems, they are critical to the operation of the plant and the response to accidents. So there's specific flow requirements that are put on these systems, and you have to stay within those requirements. And that's where the hydraulic qualification ensures that application of the liner doesn't affect that. And then on the application side, Framatome has the in-depth non-destructive evaluation and testing experience and equipment and services, and we're deploying that to ensure that we're using those ultrasonic testing capabilities to examine the liner and ensuring that we're staying within spec and within our design thickness. So overall, we have a reduced cost, innovative pipe rehabilitation solution that provides an economical alternative to full pipe replacement. Again, going back to the problems or issues that we see as an industry and as a utility space, you have degraded buried piping and buried assets. On top of that, you're exceeding original design life on many of these components, and at the same time extending the lives of power plants. So all of that, huge need for taking action to rehabilitate this piping. And with full pipe replacement, uneconomical or impossible in some cases, where some of these piping are routed underneath major structures and components at a nuclear site. You have to look for other innovative solutions, such as the internal spray-in-place liner. With the remote robotic application, obviously that reduces manpower requirements and confined space entry, drastically increasing project safety margins, and reducing those safety risks. A wide range of pipe applications, 8 inches and up, with various configurations, allowing us to meet the needs of a wide range of buried pipe rehabilitation. Design life of 50 years, allowing you to put this liner in and get through your period of extended operation well past 60 years and on to 80 years. Engineered specifically for each application. It's not a one-size-fits-all solution, so it'd be uniquely designed for that application, considering the size of the pipe, the current degradation of that pipe, the configuration of the pipe, as well as the fluid parameters, what's the flow, the pressures, temperatures going through that pipe, all play into, and the seismic loading, all play into the design of that liner thickness. And the application range from raw service water systems to fire protection piping, mentions, emergency service water systems, circulating water systems, fire protection piping, all buried raw water piping that is severely degraded over time and is in desperate need of an innovative rehabilitation solution. So that's all for the Framatome's liner and coating solutions for buried piping. If there is any questions or comments, there's contact information, myself, Brandon Caldwell, as well as John Peters, they're the liner coating product team here at Framatome.